universal regulator tester for crew mask. On the left you'll see the altitude chamber, there's the computer on the right, and all the electronics, pneumatics are behind the cabinet. Greg is going to show testing an Aeros regulator in the chamber.
This is the Aeros regulator with the mask removed. First you install the regulator into an adapter. There's adapters for BE, Aeros, and Scott. Next thing you would do is select the proper test sequence. You can have there are several test sequences already created. You can also modify or create any test sequence that already exists, or create a new one from scratch. So we select the proper test sequence for this regulator. Select the test UUT button. Then you can enter the serial number off the regulator. Main reason for doing this is so that it's printed on the report. So you can, there's other information you can enter. If you want to order a work order number or a customer number, then select OK. At this point, you connect the oxygen supply line inside the altitude chamber. The first test in the test sequence is the press to test, where you just more of an operator inspection test. Once you're done with that test, you just hit abort and continue on. And then the operator instructions display the different parameters that need to be modified. The outlet, in this case, is disconnected. The supply line is connected. The regulator's in the normal mode, and you leave the altitude chamber open. Press OK. The test stand will automatically adjust the inlet pressure to the value set in the test sequence, which is derived from the CMM. Next, it tells you to close the lid and lock it. And this right now is performing the outlet and overall leakage test. So you can see the leakage is creeping up. It's about 1.8 cc's. Once the leakage rate stabilizes, the test stand will record the data. You can see the test result is 1.7 cc's. The limit was 10. So it passed that particular test. Now it's displaying the instructions for the next test, which is selecting 100% mode. And the chamber's still open at this point. Pressurizes the regulator and closes the lid. It's performing the same outlet and overall leakage test with the regulator in 100% mode. At this point, we're testing the oxygen dilution. So the operator instruction tells us to switch the regulator to manual mode, connect the adapter onto the fitting inside the chamber, and close the lid. At this point, the test stand is using our external vacuum supply to run the vacuum level inside the chamber to 5,000 feet. Once the altitude is stable, the inlet pressure is stable, and the flow rate are all stable, then it'll monitor the oxygen concentration. Once that becomes stable, it'll give us a reading, and it'll move to the next altitude level.
Oh. Yeah. You touched the barn house.
Currently we're getting 30% oxygen or 193.7 millimeters of mercury partial pressure. That test passed, now it's moving on to the next test, which is headed toward 10,000 feet. At any point, if we had to back off the regulator, we could stop the test where it was at and adjust the regulator to the proper dilution. When it gets on the next step, we'll demonstrate that. Right now we're stabilizing on 10,000 feet. The inlet pressure is at, the indicator's green, so that's how you know it's within tolerance. And the flow rate, 20 liters per minute. So recording the oxygen concentration at that point. You could also run any of these tests individually, one at a time. So if I just wanted to run the test at 15,000 feet, we could select that test. We could press. So it passed the test at 15,000 feet. Now it's moving up to 20,000 feet. If we wanted to make an adjustment at this point, we could press this test hold button. Now the test stand will stabilize at 20,000 feet, 0.42 MPa and 20 liters per minute. If we had to back off the regulator, we could move the tooling in and adjust the oxygen dilution aneroid to get the proper value. And then release the test hold button and continue on with the test. Like currently we're doing a 30,000 foot altitude dilution test. During this time, we're monitoring the flow and compensating for the amount of oxygen that's being delivered. So if we're at 98% oxygen, then we compensate our flow rate for that, for the gas mixture. The barometric pressure is also taken into account along with the test gas, the temperature. So the printout displays the information we entered at the top of the screen for the regulator part number, has the date and time, and the operator's name. Then it lists all the tests that were performed, the measured value, the low limit, the high limit, and the result, whether it passed or failed. And at the top, it will display pass or incomplete based on the results of the test. Now we're going to test the top level assembly. Like before, you select the proper test for this mask, then insert the rubber adapter for this style of mask. We have different adapters for the Aeros full face or one piece, or the BE mask. Select the test, enter the serial number. This is a fairly quick test. This particular regulator only has a few tests that need to be recorded. We'll start with the inward leakage test. The outward leakage test can be performed by putting the mask inside the chamber, closing the lid as the regulator would. So to do the inward leak test, just inflate the harness, place the mask over the fixture. Informs the operator to select 100% mode and make sure the mask is installed. Turn OK, hit OK. And you can see the outlet pressure is building to the preset value. And we're monitoring the leakage rate for this particular mask. Once the pressure stabilizes, the indicator will turn green. Then we'll monitor the leak rate and verify that when it's stable, we'll take the reading. Everything is performed inside the test stand. It's all automated control. There are no manual regulators or flow indicators to look at. You can see the outlet pressure is stable, or is within tolerance. The leak rate is stable. It's recorded in the data. And the test result is passed. The leak rate was 5 cc's. Now you can inflate the harness, remove the mask, press, and continue button. And this particular mask passed all the tests, so it's conforming manner.
You're seeing the complete testing of both regulators as a regulator and as a FOA product in the mask. This is a calibration screen. The software provides the ability to go in and calibrate the unit. It's about a 1-day calibration needed every year, traceable back to NIST standards. Other items we have abbreviated. All the software allows an easy modification of the test programs by taking one product and cloning another product from it. Things you expect in quality software. This complete test system again is fully automatic. No adjustments required with operator using manometers, circular gauges. Fully compensates for the current operating temperatures, barometric pressures as the tests are being done. In testing the regulator, typically one has a manual operation test, but then there's 15-20 minutes of time that the unit is running fully automatic where the operator is available to do other functions at that time. This is the working part of the tester, approximately 2 bay wide, half bay height tester with the pneumatics, all the sensors, the flow valves, mass measurement systems. This is where the functions are being done.